right, so we are looking at radian and degree measure today. You have a worksheet today that kind of reviews all of this. Everybody's attention's up here. And yes, I did put the answers online. That's right, Michael, pay attention.
Yeah.
All right, so an interesting fact. Trigonometry, did you know that it means measurement of triangles? Trig uses triangles all the time, doesn't it? We're always using triangle and trig, so always go back to the triangle. So I love this fact. Well, it's not a fact, it's amazing. All right, so you have to know what your initial side of your angle in the unit circle, and the unit circle is in the coordinate grid. Is that fuzzy or just me?
Yeah, it is a little bit.
It is fuzzy and it's just you.
Stop.
I'm trying to concentrate.
Everybody's chatty today, and I don't know why.
I did soda. Probably because tomorrow's a half day on this Friday.
We're excited to see you again.
Oh, that's it.
Today's been a
There we go. Finally. But now we can't see the whole thing. Okay. So in the coordinate grid, your initial side is always going to be 0 degrees. So isn't this 0 degrees here? And isn't this 90 degrees? 180? What's this? 270, 270, and then this is 360. All right, so your initial side is always here. And then this is the degree that's being measured from that initial side to that terminal side. And this right here is called your central angle. We can create triangles from the central angle just by going straight down, right? Now don't I have a right triangle? So everything that we're going to do is based off of that right triangle. So you can get a positive angle by moving counterclockwise, or a negative angle by moving clockwise from this initial side. So clockwise is with the clock. Now y'all are from a digital clock generation, right? But don't the hands of a normal clock go this direction? So that's clockwise. So if I move this initial side down, I'm going to get a negative angle. If I move the initial side up, I get a positive angle.
How do you have a negative?
Well, let's just say I move it down 30 degrees, it's negative 30 degrees.
Okay, so, like, theoretically speaking, in real life,
It's still, well, there are some things that you would have a negative angle with. So yeah, you can have in real life a negative angle. Most of the time do we deal with a positive? Yeah.
How is that possible?
Yeah, how do you do? I don't get.
I can just go
But
down.
that would be the opposite. That would just be like 370 or 350.
No, you just, no, because 350, well, let's just say this is 30, right? So 330 degrees would be from here all the way around to here.
Yeah.
That would be 330 degrees, but this direction from here to here is negative 30 degrees.
Okay, but there's no actual like.
Yes, there is. I'm telling you there is. You
Right.
can have negative degrees, and you get a negative degree by going clockwise. Take it as fact. That's how it works.
Wait,
Yes.
so how am I doing that with
You
the
owe me
negative?
$20.
Yes. If you go clockwise, and you'll see what I mean shortly. We're going to do some problems related to that. All right, so then we have to talk about what's this thing called a radian. I'm going to pull it out, so it's going to be a little fuzzy, sorry. Your radian is the measure of your central angle, the part that intersects the arc. So this right here, from here to here, that's 1 radian, let's just say. That arc right there, that's what we're measuring in radians, is the length of that arc. So in geometry, you found arc length, right? And you found arc length by taking the circumference of the circle and then the angle portion that that circle was and multiplying it. You had to have some measurements in there. You have to have radius of the circle and that kind of thing. But you remember doing that? You were actually finding a radian measure. Now, it's not technically in radians yet. We'll talk about that. And then over here you can see that this circle is split into a little over 6 radians, right? So from here to here is 1 radian, 2 radians, 3, 4, 5, 6. We didn't quite reach up here. What is this in decimals? This 0 degrees right there. So if that's 0 degrees, right at 0 pi, and you have pi, aren't you, in radians? Do you remember that from last year? Right? And then if this is 90 degrees, this is 180. Isn't this 1 pi? 0 to here is 1 pi. 90 degrees is half a pi, right? And a full circle is 2 pi. Remember that? The full circle is 2 pi. So this is 3/4. This is a pi and a half, isn't it? So 3/2 pies to get the 2. So what's the decimal equivalency of pi? 3.14. So 3.14 is over here, isn't it? What's half of 3.14? So half of 3 is 1.5 and half of 14 is 0.07. So what's 1.5 plus 0.07? 1.57. So isn't this 1.57 pi? Because you're going to have to know the decimal equivalency, right? Uh-huh. And then you're going to have to take the 3.14 pi and add 1.57 pi to it to get this one. And then what's this decimal equivalency for 2 pi? 6.28. Okay. So let's go ahead and look at that. So take a straight edge. And then we're going to take this circle here and we're going to split it into sixths. Well, really twelfths. So I'm going to split this part into sixths and this part into sixths. So split your circle into twelfths. Evenly. Evenly as possible. Your splitting should go through the origin, right? We're preparing for Thanksgiving. 12th, yeah.
Are we gonna have a Friday?
We will. March the 14th or whichever is closest to a school day.
Oh, I'm just
That
wondering.
makes me sad.
Some schools probably do look at that. They don't actually get to do it.
No, we actually get to.
We should do math equations.
Okay, so I'm going to use some different colors here. This is 0. This is 90 degrees. This is what over here? 180. What's this? 270. And then it again becomes 360, right? So those are your degrees, but not quite. So if this is a total of 90 degrees and I split it into thirds, isn't this 30 degrees here and 60 degrees here? Right? What's 90 plus 30? 120. What's 120 plus 30? 150. What's 80 plus 30? 210. 210 plus 30? 240. Then we have 270. What's 270 plus 30? 300 plus 30, 330. Okay? So, I really didn't memorize a whole lot there, did I? Was it too hard to come up with those? We still have some more that we do have to come up with. So in addition to this, we also have, we take this 90 degrees and we split it into half. So half would be right here between 60 and 30 degrees. What's half of 30 degrees?
45.
What's half of 30? 15. So 30 plus 15 is 45 and half of 90 is 45 degrees, right? So then over here, what's 90 plus 45? What's 90 plus 45? 135 degrees, right? Then over here, between these two, I cut this quadrant in half. What's 180 plus 45? 225. And then over here, I cut this one in half. What's 270 plus 45? 315. So I don't memorize any of those. All you have to know is these. and then these will start to fall into place, right? So that's one thing that you have to know. You have to be able to recreate on your unit circle, okay? Then, let's look at the radian measure. So this is also 0 radians right here. And then this is pi over 2, right? Because it's half of a pi. And this one is pi. And then this right here is 3 pi over 2. And then this comes back to 2 pi. That's your...
Can you zoom in on that a little bit?
Sure. There, is that better?
Yeah, that's better.
Hang on, let me bring it down a little bit. Oh, it's much.
Over pi?
No, it's just at 0 degrees, this is 0 radians. At 360, it's 2 pi. So at 0, I have to have 2 different values. And of course, if I keep going around the circle counterclockwise, I would have doubles for everything. I could do it infinitely too, but we're not going to. We're going to stop at 2 pi. All right, so let's continue with the radians here. Does anybody know what this radian degree is for 30? I'm going to show you how to convert.
Is that what I know?
Yes, that's 3 pi over 2. This one is pi over 6. Does anybody remember the conversion to radians?
You put 30 over 1 and multiply it by.
3 over 1?
Or no, not 3, like the 30 and then like 3 over 1. 3 over 1 and then
Times
times pi.
pi over
1.
180. So your conversion is pi over 180. So think of it this way. How many times does 360 go into 180? I'm sorry, did I say that wrong? How many times does 30 go into 180? It goes in there 6 times, doesn't it? That's why it's pi over 6. So skip the 45. We'll come back to that. How many times does 60 go into 180? 3 times. So this is pi over 3. What do you think this one is? Do you remember what it is? How many times does 45 go into 180? 45 goes into 90 how many times?
4.
So look, 1, 2, 3, 4 times, doesn't it? So it's pi over 4. And think of it this way. There are 1, 2, 3, 4, 5, 6 30 degrees right here in 180 because this whole half a circle is 180. So, and 180 is pi. So this is 1/6 of the pi. The 45, there are 1, 2, 3, 4 45s in that pi, right? So this is 1/4 of the pi. And then for this, I have to go 1, 2, 3. There are 3 60 degrees if I count by 2's, right? So that's 1/3 of the pi.
For 90 degrees, is that pi over 2?
It is pi over 2.
I thought it was just half.
It is half a pi. So half a pi, pi over 2, right? So then 120 is how many degrees away from 90? Because I'm trying to get you away from memorizing. So it's 30. So this is 1, 2, 3, 4 pi over 6. 4 pi over 6 reduces to what? 2 pi over 3. See how I'm not memorizing? All I did was, this is a difference of 30 degrees right here, right? Do you see? Well, then you're going to have to figure it out on your own. This is a difference of 30 degrees. I don't know how else to tell you. So this is, right here is 1/6, right? So if I count by 6,
Oh, okay.
1, 2, 6, 3, 6, 4, 6. I'm just counting by 6. So then this one is a 45 again, right? So let's count how many 45s. Here's 1 45, 2 45s, 3 45. So it's 3/4 because 45 is out of 4, isn't it? So this is 3 pi out of 4 because the 45s go by fourths, right? Now the 150 is 60 away from here, isn't it? You could still look at it as it's 30 away from here. You could count it as either by 60s or 30s. It doesn't matter, really, does it?
So it's 1.
Because it's 30 degrees away from here. You've got 1, 2, 3, 4, 5. 5 30s, right? So 5, 6 pi, right? So isn't this 5 pi over 6?
Wait, if we just memorize it, or we do it?
You can memorize it. That's a lot to memorize, though. So you're welcome to memorize it. But I just count by sixths, by thirds, and by twos.
Well,
That's all I do.
I get the degrees just fine. What I don't get is, so pi over 3 and pi over 6, that makes sense to me, but shouldn't it be pi over 4.5 because that's half of 3.6?
Where are you looking? Here?
Yeah, right.
But this is 45 degrees. From here to here, then we start counting fourths. I just didn't mark the fourths in here because it gets confusing. You have to know that this is a fourth. And you have to count by fourths. So then we're going to do the rest of these. Are you ready? Isn't this just 30 degrees away? Isn't this 30 degrees goes in sixths? Isn't this 6 6 here? So what is this?
7, 6.
7 6. See? So 7 pi over 6. Then this is another 30 here. Skip the 45. This is another 30. So isn't this 8 6, which reduces to what? 4 thirds. So 4 pi over 3. And look across. See how it's reflecting across from something over 3? That's how you can check it, right? And this reflects as something over 6, right? So this was 8, right? So isn't this 9? What do we do? So 6, 7, 8. This was 9 6, right? Doesn't 9 6 reduce to 3 halves? So this is 9. This is 10. 6, because I'm counting by 6. What's 10 6 reduced to? 5 pi over. And look at where it is. It's reflecting across from the 3 line. So 3.
Wait, what about 2.5?
We're getting back to those. We're coming back. We're only going to count by 6 right now. So this is 10, right? So this is 11. What? Pi over 6. And then we reach 12 pi over 6. Isn't that 2 pi? So I did all of that. Now I'm going to go back to my 45. So now count by fourths again. So remember, this was 1/4, 2/4. This is 3/4, 4/4. What's this? 5 pi over 4. Then this is 6/4, right? So this is 7 pi over 4. And then this is 8/4, which is 2 pi. Do you see how I'm trying to make it systematic? I'm not memorizing anything. All I've memorized is this. The rest of it I'm counting and thinking, and we'll reflect in a minute too. We'll do some reflections with other things. For right now,
Hey, when we did this,
don't even start with me with that. This is being air traffic controller, here you go. Anything dealing with trigonometry with measurement, here you go. Radar, here you go. I mean, it's all over the place.
No, I didn't think that.
It's very useful. Now, I don't know if you're ever going to use it.
Yeah,
I don't know. You don't know. I thought I was going to be a jet fighter pilot when I was sitting down in that chair. And look at me now. See? I was going to be an astronaut. Look at me now. All right, here we go. Next one. Let's look over here. So now we're going to be doing some, we're going to find coterminal angles. That just means that they end with the same terminating side. We're going to find a positive and a negative one. So remember, with this circle here, I can go, if I go in one full revolution, haven't I gone 2 pi? So if I go a full revolution and then another 30 degrees, haven't I gone 2 pi plus pi over 6? What is 2 pi as something over 6? Do you remember? 12 pi over 6. So this would be 13 pi over 6, wouldn't it? So 13 pi over 6 and pi over 6 are coterminal. Pi over 6 is just 30 degrees, right? But 13 pi over 6 is a full revolution plus 30 degrees, so it's 390 degrees.
Like if you subtract 12 from 13 6.
Well, I'll show you how to do that here in a
Oh,
second.
no, I get that.
But yes.
Yes.
All right, so let's look at 13 pi over 6, what we just did. We're also going to find its negative. So you always want to be adding or subtracting in full revolutions. So you always want to add or subtract in units of 2 pi. So if I take 13 pi, divide 6 into 13, it goes in there twice, right? What's left over? 1 pi. And so we already determined that, right? So 13 pi over 6 is the same as 2 pi plus pi over 6. Agreed? Okay. So that means that one of my coterminal angles can be that pi over 6. Here's one of them. How many degrees is that? 30 degrees, right?
300.
So all I have to do is choose anything else that ends up at 30 degrees. If I wanted to take 30 degrees, well, this right here, the 30 degrees or 390 degrees going all the way around, those are coterminal. And I could do it again, right? Take 390 degrees and add another 360 degrees to it, correct? But they've given me the angle in terms of radians. So I'm not adding 360, I'm adding 2 pi, right? But when I added 2 pi, I got the 13 pi over 6. So how did I go from 13 pi over 6 to just pi over 6? What did I actually do? Yeah, so I actually took my 13 pi and I subtracted my 12 pi over 6 because that's the equivalent of 2 pi. And so that's how I got pi over 6. Now if I want a negative coterminal angle, if I do it again, if I subtract, or if I add another 2 pi over 6, I'll get another positive, right? So if I take this and add 2 pi over 6, I'll get a positive. I already have a positive. I want a negative. So don't I have to subtract it again? Take, nope, take from pi over 6, because that's where we ended up after we subtracted it once, right? And I want to subtract 12 pi over 6 again to get my next one. Or you could have taken and subtracted 24 pi over 6 from 13 pi over 6. It doesn't matter how you do it, so long as you look at it as 1 versus 2 revolutions. So what's 1 minus 12? Negative 11 pi over 6. Let's think, is that true? Look at your circle. So go back over here. If I drop down to go negative 30 degrees, isn't this 11 pi over 6? So if I go in radians and I drop down going clockwise, this becomes a negative 11 pi over 6. See? But isn't 11 pi over 6 considered 30 degrees? If it's positive, though, it's not 30 degrees. What is it? If it's positive, it's 330 degrees. If it's a negative 11 pi over 6, it's... But watch it this way. Watch it this way. We want it to be coterminal over here, though, right? So from here, go 11 in the negative direction. You ready for this? Because this really isn't negative 11 pi over 6. Watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What did I subtract? Oh, I want it from here. Sorry, I started up here, didn't I? I started from the wrong spot. So starting up here, I'm going to subtract 12 pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got back in the same place, didn't I? But because I went negatively, this is considered also negative 11 pi over 6. Because I went backwards. Watch what happens. Could you close the door, Mike, please? Just close it, so that we don't have to listen to you listening to them. So close it. Watch what happens. From here, I went positive 1, 6, right? There's your positive 1, 6. But then since I'm going negative, here's 11 more. I'm going all the way around that are negative. That's why I end up with a negative. Because the minute I go down to here, that's negative 1 pi over 6. Negative 2, negative 3, negative 4, negative 5, 6, 7, 8, 9, 10, 11, negative 11. Because here I got to 0. Is that why, does that make sense why it became negative 11? Okay. But we're going to do it algebraically. You don't have to use your circle. But I wanted you to see how that happens. Yes?
I was gonna ask you that.
No, I just wanted you to see that they actually are coterminal. They end up in the same place.
Do we have the option to use the circle?
Yes, you can. You can. It's a lot easier to show your work, though. Watch, we're going to do some more here, and it'll be easier once you figure out what you're doing. Abby?
How did you get 2 pi plus pi over 6?
Where are you looking? Oh, here? Because I just took 13 and divided it by 6. How many times does 6 go in there evenly? Twice, with 1 left over. I basically changed it to a mixed number. All right, so 3 pi over 4 is less than pi, right? 3 pi over 4 is over here, correct? So we want to find something that's coterminal going from here to here. It ends up here also. I could do another full revolution, right, this way, or I could go the opposite direction and do a full revolution that way. So we're going to take 3 pi over 4, and we're going to do 2 different things. Since it is less than a full pi, I'm going to add to this a full revolution. What's a full revolution in terms of 2 pi as something over 4? What's 2 pi as something over 4? 8 pi over 4. So what if we added 8 pi over 4? Aren't I adding a full revolution? What do I get? What's 8 plus 3? 11 pi over 4. This would be coterminal. That's its positive coterminal. If I want to get a negative 1, then I'm going to take 3 pi over 4, and if I subtract 8 pi, am I going to get a negative 1? If I don't, I would just subtract 8 pi again until I got a negative 1. That's 1 full revolution over 4. It's 2 pi. I'm either adding or subtracting 2 pi. That's a full revolution every single time. How am I going to get back to here? This is where I want to be, right? The only way I can get back to here is if I do a full revolution to get there. And what's a full revolution? 2 pi. A half a revolution is pi. A full revolution is 2 pi. So all you're doing is you're not starting at 0 anymore. So if my starting point is 3 pi over 4, and I want to go a full revolution is 2 pi. So all I did was add 2 pi here to 3 pi over 4. I should end up in the same place. I'm going to prove to you that I do. Shall we count it? If I start here and I add 8 pi's over 4, so add 8 fourths. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Didn't I end up there? But since this was already 3 pi over 4, count. 4, 5, 6, 7, 8, 9, 10. This is 11 pi over 4. Isn't that what we got? So now we're going to count backwards. So now we're going to subtract 8 pi over 4. So if I subtract, what's 3 minus 8? So negative 5 pi over 4. That just means that you're going in the opposite direction. If I'm going negatively, I'm going counterclockwise, right? How does that happen? So if I start here, and I want to count 8 times, because I'm subtracting 8, right? So 1, 2, 3. Those are all positives, right? Now aren't I moving into the negative realm? How many negatives do I get? 1, 2, 3, 4, 5. Wasn't it negative 5 pi over 4? Here we are. So like for you it makes sense on the circle, but for you it makes sense algebraically. Each to your own, right? Alright, so do the same thing with this one. This one you're starting off with a negative 2 pi over 3. Where is that on the unit circle? What quadrant? You're not going to see it on here. What quadrant is it in? You're starting here and you're going negative 2 pi over 3. Count by thirds. How many thirds are you counting? 1, 2. This is negative 2 pi over 3. So we want an angle that ends here. Wouldn't 5 pi over 3 be one of them? Right? How do we get that? So take this and add, what is a full revolution over 3? What's 2 pi over 3? Take 2 pi and multiply it by 3, what do you get? 6. So it's 6 pi over 3. What's a negative 2 and a positive 6? Okay, so we get 4 pi over 3. Now subtract, because that gave us a positive one, right? So negative 2 pi over 3 minus 6 pi over 3. What do you get now? What's negative 2 and negative 6? Negative 8 pi over 3. So we could count by thirds again if you want. Count by 6 thirds and we'll still get to that same place. Yes?
So then the problem for you requires to use the pi?
Absolutely. That's why we're doing it. Yep. You're going to have to use this a lot.
No, I can use the algebra.
Oh, you can use the algebra. That's how I would do it. I won't count on the unit circle. I'll always use my algebra. So there's that. So, and then write yourself a note down here. Always add or subtract full revolutions. Multiples of 2 pi. We didn't have to add or subtract by 2 pi. Whoops. We could have added or subtracted by 4 pi, or 6 pi, or 8 pi over whatever. So long as it's multiples of 2, because those are full revolutions. Okay? All right, so flip it. Now we're going to look at complementary versus supplementary angles. So remember, complementary angles add up to 90 degrees, and isn't 90 degrees pi over 2? Supplementary angles add up to 180 degrees, and isn't 180 degrees pi? Right? Yes? Okay. So then, if possible, find the complement and the supplement of the following. So we're going to find the complement first. So think of it this way. Oh, I guess we're doing it of each one of these. So this one, we're going to find the complement first. So if I knew the degree measure, because this is in radians, so if I knew the degree measure, let's just say it was 40 degrees. If you knew that that was 40 degrees, what's its complement? 50. How'd you get it? You took 90 and subtracted that angle. So we're going to take 90. What's 90 in radians? What radian? Pi over 2. So we're going to take pi over 2 and subtract 2 pi over 5. We don't have like denominators. True? Mm-hmm. So what would be the least common denominator? 2. So I'm going to multiply this by 5 and this by 5, this by 2 and this by 2. So I end up with 5 pi over 10 minus 4 pi over 10. If I get a positive answer, life is good. What's 5 minus 4? 10. So I get pi over 10. So that's my complement. If you add those together, you should get 90 degrees. 2 pi over 5 and pi over 10. Right? All right, so then my supplement, we're going to do the same thing, but subtract it from 180. What radian measures 180? Pi. So we're going to take pi and subtract 2 pi over 5. So isn't pi over 1? Our LCD is 5 this time, so multiply top and bottom here by 5. I get 5 pi over 5 minus 2 pi over 5, and what do I get? 3 pi over 5. So there's my supplement. So then do B. You can either do it on your own or listen to me. So start with a complement. So starting with 90 pi over 2, I subtract 4 pi over 5. LCD again is 10, so times 5 times 2. I get 5 pi over 10 minus 8 pi over 10. What happens? I don't have, if this is 180 degrees, aren't I subtracting more than 180 degrees? What did I just do? Yes, if this is 180 degrees, or 90 degrees, sorry, aren't I subtracting more than 90 degrees? So I end up with a negative 3 pi over 10, which is not possible. So sometimes you're not going to have a complement or a supplement. So try your supplement. So 180 is pi minus 4 pi over 5. Pi is over 1. LCD is 5. Oh, thanks. So then we have 5 pi over 5. This time I can take away 4 pi over 5. What do I get? Pi over 5 is the supplement. So that's not so bad, right? Are you okay with that? Mike, are you on overload yet?
No.
Okay, this is good. All right, so let's convert degrees to radians and radians to degrees. So this is pretty simple. All you have to remember is that the basic conversion is down here. Pi is always in rads, radians, and it equals 180 degrees. So 1 pi, which is radians, equals 180 degrees. So if you forget, think of your unit circle. So if you're converting into radians, you've got degrees and you want to convert into radians, make sure your pi is up top. Because remember what the unit circle says, in radian degrees, isn't pi up top, not in the bottom? So make sure that you multiply with pi over 180. If you've got radians and you want to convert it to degrees, then put the 180 degrees up top. Whatever you want to convert it into, that's what goes up top. So if you're converted to radians, pi goes up top, degrees, 180 goes up top. So look at example 3. We're converting from degrees to radians. So I'm going to take 135 degrees and I'm going to put it over 1 and I'm going to multiply. Since I'm going to radians, I want my radians up top. So pi over 180. Reduce what you can. Yeah, what goes into both of those? Well, at least 5, right? So 5 goes in here twice with 3 left over. 5 times 7, right? 5 goes in here, 3, 15, with 3 left over, 36. What goes into 27 and 36? 9. So 9 goes in here 3, 9 goes in here 4. So don't you end up with 3 pi over 4? And if you check your unit circle, isn't that where we put 3 pi over 4? Was that 135 degrees? All right, this time we have a negative. It doesn't matter that it's negative. Still put it over 1. Because we want to convert to radians, the radians go up top. Degrees are on the bottom because you want your degrees to cancel. My zeros on the end cancel. And all you're reducing is 27 and 18. What goes into both of those? 9. So 9 goes in here 3 times. 9 goes in here twice. So we end up with negative 3 pi over 2. So going from radians to degrees is exactly the same except for you flip it. So this time if I'm going 2 degrees, they've given me rads. I don't even write rad in there. I just write negative pi over 2 times. And if I want degrees, I put my 180 degrees up top and the pi on the bottom. Because I want these pi's to cancel out. 2 goes into 180 90 times. And so I end up with negative 90 degrees. Of course, if you already knew that pi over 2 is 90, then negative pi over 2 is negative 90 degrees. This one's interesting. It's just a 2, isn't it? So look what happens. And this can happen too. So I've got 2 over 1 and it's rads. Remember, we're converting 2 degrees, so you want your degrees up top and your pi on the bottom. There is no pi to cancel out because this is in decimal rads. We've taken the pi, 3.14, and multiplied it out already. So nothing cancels, right? So you actually get 360 degrees over pi. That's actually your degrees. Weird, but true. And then if you actually wanted the true degrees, then take your calculator and then take 360 and divide it by not 3.14 but the actual pi. And your pi button can be found above your caret key right here. So it's on your second function. So second function, caret, and then hit enter. And go out to 2 decimal places. What do you get? Yeah, so this is approximately 114.59 degrees. So you like the second page, don't you? I wore you out with the first page. All right, flip it. This you need your calculator for. So this is kind of fun. You're converting from minutes or degrees, minutes, and seconds. Back and forth. So we can get it to its decimal equivalency versus its degrees, seconds, and minutes. So look at part A. The only thing that's not on here is, and part of your homework has minutes. For whatever reason, minutes isn't on here, but I'll show you where it is. Or seconds, sorry. Your seconds can be found on your, above your plus key. Can be found above the plus key. You must use your alpha. Because it's not second function. See how it's the same color as your alpha key? So my alpha key is green. So right above my plus sign, do you see, where did my plus sign go? See here it has these two, what looks like quotes, little quote marks? That's seconds. All right, so here's how you get the rest of it. So if I'm going to put 40 degrees, 20 minutes into my calculator, I'm going to put 40 degrees, just 40 in. To get to degrees, look for your angle. See above apps how it says angle? So hit second function, angle, and see how you have a choice at number 1 there of the degree symbol? So hit degrees, and so now it reads 40 degrees, don't do any spaces. Then put in the 20, and go back to your angle again, so second apps, and then you have degrees, or minutes, sorry, right below that. So scroll down to minutes, hit that single tick mark, and that in your calculator is telling you 1 its decimal equivalency of 40 degrees, 20 minutes, no seconds, and hit enter. And you get what? Yeah, 40, and because the 3 is repeating, I just put a repeat bar over there. And that's technically in degrees. And then you do the 27 minutes, 15, or 27 degrees, 15 minutes on your own. See what you get. Yes. Okay, so I'll run it through with you. So we're going to hit 27, right? And then go to second function. Find your apps key. Hit apps, and then hit enter. So you have 27 degrees, then hit 15. And go to your apps again, second function apps. And scroll down to 2 or hit 2. And hit enter. And now you have your 27 degrees, 15 minutes, and hit enter. So this one is 27.25 degrees, right? Yes. All right, now if you want to go from the decimal to your degree, minutes, and seconds. So try this. You're going to put this degree in your calculator. So you got 310.75, and that's your degrees. Then you want to go to second and hit apps again. Oops. And do you see down here where it has DMS? You want to scroll down there or hit 4 and hit DMS and then hit enter. What did it give you? Yeah.
Can you just like look at it and tell those?
No, not for this one.
Well, you can tell
Well,
0.75
yeah.
is 3/4.
But I need to show you how to do it though, right? So that's how we got that answer. So that you do the other one on your own.
Why didn't you put in the
You didn't
degree
get that
sign?
one.
I never put the degree sign for that one. And it
I didn't
says-
have to.
So you totally don't have to put it in the degree sign it then?
Yeah, I don't.
But your instructions here says.
Yeah, these instructions are not right. These are for the old calculators. Just, who has the old calculator?
It's not working.
Let me see your old
Do we need to
calculator.
do
That could be
for
why.
your calculator?
Yes, for
It
my
work-
calculator.
It works without the mark. Without like the.
You have to put your degree symbols in on the old calculator. The new calculator, I didn't have to.
No,
No?
no, because I was just following the instructions on my.
0.75, so you put it in without.
Is it in your calculator?
I have both of them on here. I just follow the instructions.
What do you do if you have the new calculator?
Okay, so it can either follow those instructions or, so here's Amber's calculator. I followed without the degrees, and didn't we get the same answer?
Yeah.
So I think my directions are much more clear. I don't know.
It's because I
It works.
think it's because the calculator, you have the settings on degrees instead of rads.
Oh yeah, that could be. Try it with rads. Do you know how to change the degree setting in your calculator? Because this is in degrees. If you're putting degrees in your calculator, you really shouldn't put rads in your calculator. So do make sure that your mode, mine's in radians, doesn't really matter. But I wonder if you put it in degrees if it would change.
Mine was in degree and
Did it do it also?
it was fine and it got the same answer either way.
Yeah, because usually I don't pay attention to that. Yeah, so it didn't matter. I will explain how to do 7 and 8 tomorrow, but we've gone up through here, right?